it's true geometrically. Okay? Property number 5, if you take two numbers and add them and take the modulus, it's less than or equal to the sum of the moduli. This has a name. This is called, right, the triangle inequality. That's what it's called. Proving it algebraically is somewhat more tricky. Okay, you can do it. It's not too hard, but it's not a half-liner. You have to write a bit. Okay, but the geometric proof of this is very easy. Okay, if you remember that addition of complex numbers corresponds to addition of vectors. So the idea of this, the geometric idea, I'll draw a little picture here, So suppose that, let's say, this is z, this corresponds to z, and therefore the length here is the modulus of z, and let's think of this as a vector, okay, of length modulus z. Okay, let's just call, okay, this is confusing what I'm doing. So this is the vector corresponding to z, and let's have another vector corresponding to w here. So this corresponds to w, and remember how we add them. How we add vectors. We draw a w starting where z ends, and then we take the diagonal of this parallelogram that we get. So this in red is z plus w, right? And this statement merely says that the length of the diagonal, the length of the vector z plus w, the red one, is greater, is less than the length of z plus the length of w, okay, which corresponds to the statement that taking the straight line between 2 points is always the shortest distance, and in particular shorter than going via a third point. Okay, so z length plus w length is greater than or equal to going the straight way, z plus w. Okay, and that's why it's called the triangle inequality. Okay, this, by the way, is a valid statement for absolute values of real numbers.